Hello and thank you for watching. In this help video, I'm going to go over how to evaluate the following composite functions. We have the function f, which is a linear function, and then we have this quadratic function g, and we want to evaluate the following compositions. Let's start with the first one, a. To do this composition for a, we are going to follow the following order. We're going to evaluate the function g at the value of 0, and then evaluate the function f at g of 0. So for letter A, we're going to start with step number 1, which is g of 0. So we're going to look at the function g, which is negative 9 times the value of x to the second power plus 3 times the value of x, and we're going to replace those x values with 0. So negative 9, 0 to the second power is 0, 3 times 0 is equal to 0, and negative 9 times 0 is 0, and 0 plus 0 is equal to 0. So we get that the value of g at the input value of 0 gives us an output value of 0. So what we're going to do now is we're now going to evaluate function f. So step 2 is to get function f and evaluate that at this input value of 0. So function f is 3x plus 1. And we're now going to evaluate this at 0, which would mean 3 times 0 plus 1, which is an answer of 1. So there's your response. So this one right here equals to a total of 1. Now for the second part, for part B, we're going to evaluate in the following order. We're going to now get g of f of 0. So using the same number, we're now going to plug in 0 into the first function f, and then use that output value as the input value for g. So first step is to get f of x, which is 3x plus 1, and evaluate that at 0. So this would be 3 times 0 plus 1, which is a total of 1, not 3, 1. 3 times 0 is 0, and 0 plus 1 is 1. Our second step now is to get the function g, which is negative 9x squared plus 3x, and plug in the number 1 into the input value. So negative 9 times 1 plus 3 times 1. 1 to the second power, that's just going to be 1, and 1 times negative 9 is negative 9. 3 times 1 is 3. And we get a final answer of negative 6. So that's your solution right there. So that's how you do this problem on evaluating this type of composite function in those two orders.